All right. I am taking homework from 1.2, homework questions from 1.2. We have a question for 63. It says find, write the equation or write the standard form of the equation of a circle given these characteristics. So we have the fact that this circle goes through 0, 0 and 6, 8. We got to find the radius. This is the diameter. Diameter says from geometry class. Remember that class? That's the diameter. Diameter does go through the middle of a circle, right? That's cool. Okay, so let's go with, oh, the midpoint, right? That would be in the midpoint. So midpoint formula. Oh, on your homework also, I noticed when you guys did midpoint, you did not put like parentheses because midpoint is still a coordinate, right? So you should have parentheses. It's still a coordinate system. So how about 0 plus 6 divided by 2? And 0 plus 8 divided by 2. And that would make, here it is, 3 comma 4, perfecto right there. So I think I got a portion of this equation now. I got x minus 3 squared plus y minus 4 squared. And now I'm just trying to figure out what the heck is r. So all yours. Anybody, what is r?
R is oh, 5, yeah. Well, yeah. R is 5, but when you write it out, the R is 5 squared is 25.
Awesome. Okay. Joe, how did you figure out that r is 5? It just came to you in a dream. Perfect. Yeah. Okay. So this is this is distance formula now. Is that right? Oh, that's so cool. So distance formula is the square root of, and now it's going to be between these 2 points, 0, 0, 3, 4, or you can make it between 3, 4, and 6, 8. But you know what? I like 0, 0. Way easier to work with. So how about x2 minus x1 squared plus y2 minus y1 squared. And if we do that, that becomes, looks like 3 squared plus 4 squared makes 9 plus 16 makes square root of 25. Oh, yeah, the distance, right? That makes 5. That's cool. And I know the distance here, but what I need is I need that for my equation. And in different math textbooks, you can put 5 squared. You could put 25. Both are actually accepted as a norm. Okay, that came good. Cool. Any others? Going once, going twice before you turn it in to be graded.
Number 9 and 11 really confused me.
2.3? 1.2?
Or 1.2.
Yep.
Sorry.
No problem. Guys, real quick here. No, 9 and what?
9 and 11.
11. Okay, just put it for later. Okay, let's jump with this one here. Find the x and y coordinates of the graph. This one, the graph is already given. That's cool. Graph looks like this. And you can, this one says -1, then there's a dash mark, then there's one right here. There's a +1, dash mark, and it keeps on going. Oh, this one even says 3. Just for clarification purposes.
Well,
Yeah.
I know why it was so hard. I think I did the wrong chapter.
Oh, okay.
Not what it looked like.
Gotcha. Okay.
There was this very weird symbol of like a squiggly F.
Nice. Well, other 19 as well. We're supposed to do that.
It might make more sense if I do the correct chapter.
Sure. Okay, we'll go with that. Okay, just since I already started it, are we good with -2 and 2? And 16 for the y-intercept. Totally makes sense now. Yeah. I'm trying to figure out which one you did, but that's fine. Okay.
There was like an F that was this FX equals
I think it's one.
something. It was so confusing.
All right. No, I looked at 1.1, 1.2, 1.3, 1.4. I didn't see anything like that. I don't know. Which textbook did you use? Just kidding.
Yeah, that's a good one.
Okay, guys, any other homework questions from 1.2? Going once, going twice. Okay.
What book is it? What is the title of the book? Yeah, okay, that's one of these.
Okay, I was just joking though.
Well, yeah, but
Just in case, right? Just in case. Okay, next is any homework questions, initial homework questions from 1.3.
Wait, so is 1.3 due on Wednesday?
It is gonna be due on Monday of next week. Yeah.
Oh, I'm sorry. I went astray.
Okay, 1.3, all yours. Did we? I think so, right? You guys talked to me, is that true? 1.3, I think we were, did we finish one? Yeah, we finished 1.3, yeah. So we do. Just second guessing myself. Any questions off of 1.3, Abby?
This might have just been because I was doing this at 8 o'clock, so I thought it was due today.
Uh-huh.
It was 61 and 73. I got, my tired brain got confused.
1.3, we did not do 61.
we
I
did
don't think we
73.
did.
Oh. We did 73.
73.
And 69.
69, okay, got it.
That's my bad.
73, that was the next one, I thought.
Oh, I
Yeah.
know. That is the next one.
Oh, this is 1.3. I'm a phone.
Oh,
Yeah.
oh my God.
That makes sense.
Never
Abby, I'll do 73 here.
Yeah.
Write the standard slope intercept form of the equations of the lines, the given points that first of all, that are parallel to the given line and then also perpendicular. So you got to do both. Oh boy. Okay. So that was 78, 73 actually was a tricky one. That's great. I was expecting a homework questions from there. That was a expected one.
This was too much for me.
Okay.
Yeah, that makes so much more sense. I couldn't do that.
Mhm. So we have to put it into this equation, right? We'll write an equation means I'm going to have to set it into here. I'll move B over a little bit here. I like my little lines on my PowerPoint, my little college rule background now. Thank you. So do we have a point? Absolutely. Do we have a slope? Maybe.
Y minus 0. Y minus 0,
Y minus 0.
because the y is 0.
Oh, gotcha. Yes, sorry. So this is Y minus 0. That's the little,
And
what's my slope?
Why is all?
-1x.
This one's parallel. Sorry, let me write in a few things here. Perpendicular. Okay, that one's perpendicular. Elika, go ahead.
Oh, no, I was just saying for that one, then it would be -1
Right here.
x, or wait, no, that's x, never mind.
Okay,
x minus -1.
x minus, which is x plus 1. Yeah, I'm more interested in this little slope thing right here. What's the slope thing?
So we have to do the slope. Not slope, it's the slope formula.
We're trying, yeah, no, maybe. We only do that if we have 2 points. Then we use the slope formula to get the slope off the 2 points. But if we're given a point and then also another line, so y equals -3, what does that graph look like? Here's the only time you can't sort of take.
Oh, it's a horizontal line.
It's a horizontal line, isn't it? It's right here, 1, 2, 3. What is a slope of any other horizontal line?
0.
I think 0. In fact, if we look at it here, -1. What we're trying to do is we're trying to figure out a horizontal line that goes through that point right there. So in this case, we can kind of go like this if we like. Good there? Cool. So the slope here, I'll put m is equal to, or m1 is equal to 0. That means m2 is equal to 0, right? The slope that we want is still also equal to 0. You guys talk to me, see if this makes sense. Is that good there? So that slope is what we want right there. We're trying to make parallel lines. So if this guy's a horizontal line, the line that we want has to also be a horizontal line. Therefore, this guy has a slope of 0. Okay, that becomes all 0, and that just becomes y equals 0, which actually is the equation of a line that does that.
All of this
All right.
seems very easy.
Boom, okay,
So,
I'll get it in just a bit. There goes one speaker. Okay, perpendicular. Here's the other one. is now I want a perpendicular line to this that goes through negative 1, 0. So here's my original line, 1, 2, 3. There's my y equals negative 3. What I want is I want the equation of this line right here. I want the equation of a line that's going like that. Perfecto. Okay, this is a vertical line, so y m1 is equal to 0 still, right? That's this guy, slope of this guy. The slope that I want, m2, is equal to undefined. That's all the way from algebra 1. Remember that? Vertical lines have undefined slopes. Shoot. Okay, in that case, we can't. This is the only time you can't use this formula because the formula does not make sense because there's no slope to begin with. We just take a look at this vertical line, say, you know what? What's the equation of this vertical line? I know it has to be x equals something because it's vertical. And then we just figure out a point that this line goes through, which is negative 1. That's it. Only time you don't use that formula. Okay, are we good there?
Can you say that basically the slope then is infinite or?
I will say the limit as the vertical line becomes vertical, it's infinity, yes, but not at that point. At that point, that'd be fine. Okay, are we done? Are we good? For homework for 1.3, going once, going twice. Happy Friday to you guys. Yeah.
Can we actually do 25?
Yeah, sure.
I'm
Absolutely.
pretty sure I got it, but this was the only one that I was unsure.
Yep. Yep. No, guys, this is for you guys here. So this is why we go over this stuff. Don't you guys feel privileged? The homework is for you.
I know, but that's why I was so nervous.
I'll have it left my mouth was open and it flipped to the other page. And I went into the homework on the wrong page.
Uh-huh.
Wow.
That's not the first thing.
Okay, let's jam with this one here. Noah, do you have this one? Just to go. Okay. Let's go with y2 minus y1. So y2. You came to school without a backpack?
No, I don't want to get it. I don't want to get it out of my backpack.
Oh, gotcha. Okay.
I actually did in the first.
So this is y2 minus y1, x2 minus x1, plus plus. On top, reducing this down to -1 plus 4 is just a 3. On the bottom, the denominator is already 2, but this one I do need to make it into a plus minus. So that's going to be 2. I like the fact that they have common denominators, so we don't have to do them, right? Because on the practice problem inside the class, we actually had to get common denominators. So -3 plus -11 makes -14. Oh, I like this. 3 over 3, -7, and then we don't leave negatives on the bottom. So we can either put them in front or put them on top.
So why don't you leave it on the bottom?
We just customarily say in mathematics, we don't do it. Just like order of operations. Order of operations has no inherent rightness to it. We just say this is the way we're gonna do it. Even though it helps, but it's not totally correct. Okay, are we good there? Homework 1.3, jamming. Okay, next.
I'm jamming so much.
I'm jamming out.
Okay, so oh yeah.
Bro, I would love to have some hackers. I mean, it's true.
I don't know.
All blonde, broke.
Short sponge. Oh, yeah, like.
Dang it. I am a failure
I'm on
tonight.
16.
All right, let's go with it here. So question to you guys here, let's vote. What happens if you put 30 liters of liquid nitrogen into a pool? I'm on a liquid nitrogen craze for some reason.
Alright, so is someone getting into the pool?
No.
or- Oh,
He's just
okay.
gonna dump it.
Well, that's kind of boring.
Ah, see?
He jumps in.
What do you guys say? You think the pool will freeze?
I think that the liquid nitrogen will like float on top of the
Skirt around. Okay, let's jam. Let's go for it.
What's up, everybody? Welcome back to my laboratory.
Joe, can you do that? Can you do that accent? Yeah.
Priority. It's a really hot day, so we're gonna freeze. So what will happen is 30 liters of liquid nitrogen into the pool.
Yeah, a little bit towards the Indian accent, a little bit here. Okay, let's go with it here. So,
They're very, very, very East Russian.
One way to find out, kids, do not try this at home. Hopefully you cannot get access to liquid nitrogen anyways. We're gonna do the same thing like last year we did. We put 30 pounds of dry ice, this time 30 liters of liquid nitrogen at the same spot. But check this out. All right, guys, I got you. 4 cameras rolling, 1 underwater. And you don't have proof. Right, going to dump it right in the middle.
Gotta jump in.
Oh my God. Wow.
It's gonna be so boring. He doesn't jump in there.
Yeah, Joe, I'm just thinking right now.
Oh my goodness. Wow, look at this cloud. This is insane. No way. This is way
Oh, yeah,
better
look
than
at that.
dry ice.
This looks like someone's about
Check
to walk out.
this out.
We see you jump
yeah, I wonder if you can actually use that as a fog machine.
Actually.
Yeah.
That's no fun. I thought the pool would like at least.
Maybe it makes everything to go away.
You know, that would be a better.
Wow.
It's a grenade in the ball.
That's a lot of vapor.
Yeah.
That's a good amount of vapor there. Okay. Next is, I would love to see if someone put like
Okay,
temperature
you've done.
nodes around the
Look at
pool,
that,
right? And
liquid
you dump it in,
nitrogen
just see how
nitrogen.
cold it gets, and then how, yeah, all throughout the pool.
Oh, why? You like, they're like, yeah, that's.
Also, since it looks like it has an infinity pool, it would be interesting to see what it's like, just like a still water pool.
Wait, can we pull the water moves?
No, for the infinity pool, it goes off and then. it like brings it back up.
Recycles again. Then
Look at
there's
this
the
liquid
highest pool in the
nitrogen
world,
close up.
which is Infinity Pool. It's in Singapore. It's on top of
Oh,
Wow.
up above from
Check
crazy.
this out.
130.
The liquid nitrogen just
Say again, Miles,
floating
again?
Have you seen
on the
crazy
water.
Rich Asians?
That's so awesome.
Wait,
It's like.
that's actually a real.
Got it, okay. So he's touching it, just like the other guy
Good
here.
for him.
Hey,
He's a
He's a man of Russian. He's a crazy Russian man.
It's just a hot spot.
don't you guys think it's amazing? Wow, look at this glass of liquid nitrogen just chilling on top of the water.
Uh-huh.
And also, they need an air barrier, so the air doesn't.
It's so cool. Look at it fly around. Wow, it's like sliding.
Gotcha. Okay, I'm gonna pause. I'm gonna stop here because that was kind of the fun part there.
Be stressed how little water you use with liquid nitrogen.
Oh, interesting. Okay. Okay, let's jam with 1.4. So let's talk about, did you guys do functions? Let's see, what color am I at?
Okay, that's the one I did. Isn't there a weird squiggly X that stands for functions?
Maybe. All right. Definition real quick here. What in the world is a function? So a function. And we're going to call it F. F is going to be our designation. Function F from set A to set B. And we call it is a relation. What? This is crazy stuff. We got what in the world is a relation? We'll talk about that. Relation. That, yeah, it's not a relation, it's a relation that assigns to each X in A only one Y in B. Okay, let's see what in the world this means. Okay, let's do three different things here real quick here. So if we call, this is called something called mapping. This is the mapping view of functions. But what you do is you kind of go like this right here, set it like a little blob this way, a blob this way, and you have these little points here. Dunk, 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 dunk. And you have these little points over here. And this dot here goes to this one. And sometimes you can number these if you like. You can just number them as 1, 2, 3, 4. You can number this one, I don't know, 12, 13, 14, 18. They don't have to be in order, but just it assigns one thing from one set to another and another. You're good. So whenever you have things assigning things, so something assigning something else, we call that a relation. Something goes to another thing. Okay, so this guy is called a function. And we're going to put function right over here. Let's do another one to contrast that here. So let's do this one here. Another one, another one. And I should say this here, sorry, A and B here. Here's set A. We're going from set A to set B. Yeah, we'll get to notation next here, but here we go again. One. I'm not going to put numbers next to it since you guys know those are numbers. Here's one little thing. How about this? This dot here from A goes to this dot over here. And then this dot goes to this dot. This dot goes over here. So question, is that a function? So let's see what it says. It assigns to each X in A. So this guy here, to assign each one of these guys, is assigned only one Y in B. So this guy goes to this piece. This one goes to this one. This one goes to that one. Are we good there? That's a function.
So if you have a B or a Y that is assigned two X's, but all of the X's are assigned only one Y, does that make sense? Is that a function?
Yes, all the X's are assigned a single Y, that still would make sense. I'm gonna go this way here. Let's see. 3, I guess 3, we'll see. So how about this one here? A goes to this guy. This one. This one. We'll do it. That's correct. This little piece right here, it's somehow assigned two things from that one thing. Does not make sense. Like, you know what, Mr. Gia? It's just like random dots. What does it actually mean? So let's talk about it here.
It's like a yes or no trap, where no matter what you say, yes or no, it's still means the same thing. So don't mean this.
I'm gonna think about that.
And then if you say yes, or, okay, not that exact example, no. But something like that. Like
Uh-huh.
using a double negative in a sentence.
Because I think the logic one is using an and statement, and therefore you can actually derive the true conclusion always. Well, that might be a little trivia question for Monday.
What?
Trivia on Monday.
Maybe it's a little trivia question for logic puzzles here. Okay, let's talk about this because this was all just kind of dots and stuff. Doesn't make sense here. Let's talk about this. If you were to graph, this would be a good one. Graph your position. Let's see, this is time. And this is, let's see, miles away from home. Okay, hopefully this will kind of make a little more sense here. So time would be time. So I'm going to make up some times here. So let's say this is 7 o'clock in the morning, 8, 9, 10, and we kind of go from there, right? And so I assume at midnight, the assumption is you guys are home. So you go over here and about 7 a.m. in the morning, you kind of do this, right? And then you are here for, and then we go out, then you go out to lunch if you can get off campus. So then you go like here for an hour and then you come back, and then at 3 or 4 o'clock, you go like this, unless you have sports practice, right? Does that all make sense? You're kind of, so notice that every single X here goes to exactly one Y position.
But couldn't we go further or closer than one?
Sure, I just went a little closer, that's all, so I guess. Would this make sense if I drew this line here? Yeah, that would not make sense. You can't have two Y positions for the same X, because therefore you'll be two places at once, and that does not make sense. That means someone's lying at this point, right? So that is how a function is. Function is made to be true to reality. So this X, so 8 can't go to, I don't know, we'll say 2 miles and 3 miles. That's not possible. So let's go back real quick to our chart, because it's, you have to sort of see it here. So this is my 8 a.m., right? My 8 a.m. went to 2 miles away from home, also 3 miles away from home. Therefore, it fails. It's not working the way it should. All right, and then from Algebra 1, do you guys remember something called the vertical line test? Remember that, right?
I remember it, but I don't remember what.
Gotcha. So here it is. If I can draw a vertical line test or a vertical line through 2 or more dots, I know this guy is not a function anymore. That's what the vertical line test is all about.
Can you have a vertical function though, where it only goes up and down?
Not a vertical function. What we do is we do something called conic sections. We could do it that way. Or because a vertical line, again, according to this one, makes no sense. But we use conic sections to get around that. Okay. So let's do this kind of different ways here. So first way is, let's look at points themselves. So state if the following is a function. So we look at functions as a graph. Graphically is one way to do it. We can also look at them as individual points. So tell me if this or these set of points are a function. Tell me if these set of points are a function. These set of points function. And last one here. No, and that's why we sort of talk about, you can graph them if you like, if that kind of visually helps you to sort of see it, absolutely do so. But we should be able to just sort of see it just from looking at it here.
That's the last one.
So of course, I always throw some tricky ones into here. So all yours here for A, is that a function?
Yes.
Yeah, in your mind, Abby, is that you asked if you need to graph them or not? I'm going to graph the first one, but you don't need to graph the rest of them here. So in your mind, if you think to yourself, hey, where's -1, 1, 2, 7 is about here, and 3, 6 is here. Notice the x's are not repeating themselves. Because the x's are not repeating themselves, that means they're not going to go to 2 different spots. So really what we look for, is this a function? Yes, absolutely. It's going to fulfill the vertical line test, or even better yet, you don't have any repeating x's that go to different y's. That's what you look for. Okay, no, a question.
This might just be my brain working in a different way. The next one. You have the x's out of order. So even if that was a function, then when the line go backwards?
Ah, have fun. I never said anything about any line whatsoever.
No, like if you were drawing a line.
Well, wouldn't it be just connected shape?
No, we're not connecting anything because for that we need equations. If it's individual points, it's individual points. Oh man, I forgot. That was a mess up. Okay. How about this one? What do you guys say? Yes or no? The 4 and the 12, the 4, 12 repeat themselves, huh? But do they form different points though? Nah, it's still the same point. 4, 12 is still here. It's still 4, 12, 4, 12. Does it fulfill the vertical line test? Absolutely. We are good with a yes. C, not a function, right? 1 can't go to a 2, and also go to a 3. I don't think so. That is a no. And D. Yeah, same reason for a B, right? D and B are very similar. That is yes, that is a function. Okay. That is done using individual points, right? We could also say that we actually just graphed it as well. So graphing or individual points. Let's jam to equations here, and that's what we'll stop with next. So now let's connect these pieces, or we're going to write them as equations here. So state if the following is a function. Each of the following, I guess I should say. You guys talked about x plus y equals 3. Do we know how to graph that? In fact, what do we, can you guys put this into graph mode? What do we do to put it into graph mode or graph equation?
You can subtract that from x.
Perfecto. Okay, when we subtract x, we set it equal to y. We get this little guy here, and we are ready to graph. That's a line, isn't it? But notice equation wise, because you guys are algebra 2 students, not algebra 1 students. You guys are super cool. This guy means there's, as soon as I plug in one single value for x, I'm going to get one single value for y. We good? In this case, if I plug in a 1, it becomes a negative, plus 3, it becomes a 2. Notice that? 1x goes in, 1x goes out, 1x goes in, 1x goes out. So because I have a y value that's set equal to just an ordinary equation where one value in gives me one value out, this guy is a function. Let me give you the contrast here. I'm going to just change this up just a little bit. Can you guys solve this one? Again, solving for y, because that's what we do, right? So subtract x squared from both sides. Are we good doing that? Okay, is y equal to somewhere where I can put in a single x and I get out a single y? What do you guys say? I think so, right? If I plug in, let's say, and this, you almost have to put it in your mind. If I plug in a 1 into here, right? 1 squared is 1 with a negative in front of it. Add 3, I get a 2, right? One single value for x gets me one single value for y. Okay. 4, okay. No,
No, because 1 squared equals 1.
because if I wanted to include the,
Negative.
oh, awesome. Let's talk about it real quick here. So if this is the way it's written out like this, the way you plug in the 1 is plugged in like this.
And
So
you
1
get
squared is 1.
first, and then you will.
If I wanted to include the negative into my exponent, I would write it like this. Now the negative is included. Now when I plug in that 1, it becomes this, which becomes 4. We good? If you want to include the negative, you got to put the parentheses around that negative and the number. Okay, C, and we'll finish off here. How about if I switch this guy to here?
No.
So if I were to subtract x from both sides, as we normally do, and here's our little problem right here. If I-
Plus or minus.
Good, yep, from algebra 1, you guys know that if when you do this, you have to put plus or minus. And because of that plus or minus, if I were to plug in a value for x, I'm going to get a plus value for y and a negative value for y. Therefore, this guy is no longer a function. Oh, I forgot to put yes here. No here. Are we good? Okay, you guys can do homework up to number 15 on 1.4. So I do need, let's see, I do need 1.2 homework. 1.2 homework. Let's do this here, right at the, oh, we'll do it. Is it gonna? Oh, yes, yeah, we'll do that. 1.2 homework. If you guys can put it right over here, and then also the sheet here. You don't want anyone else reading it, just put it upside down.
So,
Boom, like that.
I'm scared.
So we
I know, I
talked
hate
about
the one
having
yeah,
a separate homework.
I want to find a better
Separate
word.
notebook for
I'll
here.
say soft.
Perfect.
Yeah.
In the same line. It's like, what I'll do is I'll collect it.
I feel like I'm just bragging about myself.
Right into the cubby hole.
I said funny,
Pick it up on
loud,
the way.
and slightly.
Yeah, it's like, oh,
It's pretty accurate though.
There we go.
I feel like I'm just like bragging about myself.
All right, you guys are out of here.
Right.
That is 9:20.
There's no.